Hello guys, my name is Dylan. Welcome back to another video. Today we are going to be doing review for Calculus 2, joint proportions. So topic 1 is going to be our review. So we're going to look over two proportions for our review. There's direct proportions. So let's say we have a little person right here walking around at an even pace. And then we have another person observing this person. And so what we can figure out is that the distance is proportionate to time. And so the distance is equal to the constant time. And so the distance equals rate of time. And this works for basically anything. We have, say, the same person dropping rocks off a cliff. The velocity of the rock is proportionate to the time it takes. So the velocity is equal to the constant time, or the velocity is equal to the gravitational time. And the G here is approximately 9.8. And so we can find out the distance in time too with the same example. But we can make it more accurate by saying the distance is proportionate to time squared. The distance is proportionate to time. And the distance equals constant time squared. So the distance equals 1/2 of gt squared. And then let's say we have our person and he's being watched, and all he's doing is drawing circles. So we have small circles, bigger circles. And so the circle is proportionate to diameter. The circumference is proportionate to diameter. So C equals constant diameter. So C equals pi diameter. Okay. Next we're going to talk about inverse proportionality. So this one's rather simple. Let's say we have a little teeter-totter right here. Two things at the top. We have our person and we have our observer. So if this person pushes down on this side, which we'll call D1, then this side, which we'll call D2, goes up. And so this is an inverse proportionality. Direct proportionality, both things either increase or decrease. Inverse proportionality, one increases while the other decreases, or vice versa. So we can say that D1 is directly or proportionate to 1 over D2. And then, so we can say that D1 is equal to the constant 1 over D2. And so D1 equals L1 over D2. Let's say we have our person again, and we have our observer. What this person is trying to do in this case is push a box over to a set location. What we could say is that the time it takes to do it as with one person is proportionate to 1 over the number of people you have. So the time is equal to the constant 1 over number of people. So time is equal to people 1 over n. Therefore saying that the more people you have, the less time it will take. Or the less people you have, the more time it will take. So now we are going to move on to topic 2, which is joint proportionality. So our example is going to be the Cavendish experiment. So in 1797, Henry Cavendish measured the strength of gravity. He also discovered hydrogen. But so let's say that we have a roof here. So here's our little roof. And let's say we hung a thin but quite strong wire right here. And attached to it was a little rod. So on one end we have mass 1, or M1. On the other hand we have M2, or mass 2. What we could say is that what if we took a copy of this and moved it here? Copy of this and moved it here. We took out, and so that would mean that this would start to spin. And what we can do is we can attach a mirror right here onto the wire, and then have a light source reflect off of this mirror. What will happen is once we add these two masses, once we copy and move these masses, it will start to spin, and the light will end up reflecting here. And if you added maybe a third mass, then it would spin even more, and it would go to the third area, and keep going on and on. And so what we can have here is we have our formula, which is F is up to M1, F is proportionate to M2, and F is proportionate to 1 over R squared. This is called a joint proportionality. How we work this is we say that F is directly proportionate to M1 M2 over R squared. And so this equals force equals constant M1 M2 over R squared. And so this means that F equals G M1 M2 over R squared. Thank you guys for watching. I hope you enjoyed. I hope you learned, and I will see you next time. Bye.